What did you think of the visual we saw in the last lesson of the grid from outer space? I thought it was pretty awe-inspiring, actually, especially when you think about all that goes into it. I've mentioned this industry can be really complex, even when we're just talking about the beginning of the journey. I know you remember what that is, generation. Let me give you some perspective. There are about 63,000 power plants operating worldwide today. You heard me right, 63,000. If we're talking about the United States alone, there are about 8,000 operational power plants in the US, according to the Energy Information Agency. I mentioned that generation is the process that converts a primary fuel source into electricity. Even if you haven't heard the term generation before today, I know you've heard quite a bit about primary fuel sources. I'm talking about the natural resources that are used as a kind of starting point. And you could thank Mother Nature for these. I'm talking about coal, natural gas, uranium, water, wind, sun, heat from the earth, and yes, even organic waste. Most of our energy comes from thermal power plants, so let me grab a little time to discuss it for you. A primary fuel source like coal, natural gas, biomass, or uranium is used to heat up water and get it so hot that it makes steam. The steam makes blades spin around a rotor inside a turbine. Picture a propeller. The rotor connects to a shaft, which then spins magnets with coils inside a generator. This is what turns the mechanical energy into electric energy. Remember back to our history lesson? This is the technology that Michael Faraday discovered way back in the 1830s that I said was still in use today. Something else that's pretty interesting about the process is that the water is actually reused. It's converted back and forth from liquid to a gas. There's probably a good chance you haven't heard a lot about the process of creating electricity from the primary source. I don't think it's exactly a front and center topic these days, but the primary fuel sources sure are. We will be talking at length about some of the primary fuel sources. From fossil fuels to renewable energy sources, nothing is perfect. Each of them has some benefits and some drawbacks. It's important for you to know this as you sift through the information overload and misperceptions that are out there. There are also a few terms that we'll use when I talk about the primary fuel sources that I want you to get familiar with. Learn these and you'll be talking like an industry insider. First, let's talk about baseload. Baseload is the minimum level of electricity demand needed over a period of 24 hours. It's also called continuous load. Peak load is different. As you might guess from the name, it's a time of high demand, but it happens for shorter times. If you want to think about it as a math equation, peak demand is the difference between the base load and the highest demand.
A utility monitors the load for different rate classes. And if you looked at the load shape over a 24-hour period for a residential rate class and a typical residential customer, it's very low, during the midnight hours and into the early morning. You might have, your light out front on or something, but very little is running. Maybe your refrigerator comes on and off, but you use very little energy. Then you wake up, okay, and you take a shower and you make a cup of coffee, and you might turn up the furnace a little bit in the wintertime or whatever the case may be, but you're using energy during that, early morning to late morning period. Then everybody leaves for work or whatever, and then the load drops off during the middle of the day. And then, of course, when everybody gets home, everybody comes home, the load goes back up. Everybody starts doing their cooking, lighting might come on, all these different things. And so the load shape looks like a humpback camel, I guess, is kind of what it looks like over a 24-hour period. Whereas a commercial customer, let's just say you're looking at a 24-hour Walmart, for instance. They have load changes for air conditioning and other, but the big part of their load, all the things that they use to light the store, to run the store, if they have a grocery portion, they've got refrigeration, and so their load shape is much more flatter, and they use energy in a much more efficient way. So their system average load factor over a day is much higher than a residential customer. They don't have that big hump that I talked about. Commercial customers got slow changes in their load, especially something like a Walmart that's open 24 hours a day.
Let me break it down for you by using the example of your own house. If you're like me, you probably run your refrigerator and HVAC most of the time. That is a continuous load or base load. I don't know many people who unplug their refrigerators. But now let's think about something you use more occasionally, your microwave or a hairdryer. You would use those for shorter periods, but that use goes above your base load. This is like the peak load. Now, we need to think about this on a larger scale. Think about the millions of customers a utility might have. We've got the base load of everyone running their AC, office buildings, etc. on a typical day as we'd expect. But then we might have a record-breaking hot day, and this could be considered peak loading. Utilities plan for this, but days like this don't happen very often. Capacity is another term that's really important to know, and it's related to peak. It's the physical amount of generation that power plants can produce. Electric utilities have to have enough capacity to handle the base load plus the peak. If you think about it as a shopping mall, most of the year you can find parking with no problem. So why are there extra spaces if they go empty most of the time? Because the mall has to be able to accommodate parking for the busy times. Think holiday shopping craziness. Well, utilities have to do the same thing. They have to cover the base load, but then also be prepared for the peak demand. But unlike a mall parking lot, electricity is a necessity for us. And how many of us would accept hot or cold day as a reason for us not having AC or heat because the power's out?
There are really two measures of energy consumption, and those two measures of energy consumption are the energy component, which is the kilowatt hours, and the demand, which is known as kilowatts. How much maximum do you use instantaneously at one point in time? When a utility builds its system to serve its customers, it has to build its system to meet the maximum kilowatts, the demand that customers are going to have all at the same time. So that means that we build our system for Easter Sunday. Okay, we don't build our system just for who's going to show up every single week on a regular basis. You have to build for who's going to show up all at the same time. And so that's why when we look at how people pay for their energy, utilities are looking at it on both bases. For simplification reasons, over decades of time, to present residential customers with a more simplified view, we're only presenting them a bill on kilowatt hours.
These concepts become pretty important as we talk about the different sources used for generating electricity. Okay, ready to learn more? In the next lessons, we'll do just that. We'll take some of these primary fuel sources and we'll talk about the pros and cons of each.